Alright, so here's a problem where we're trying to find the displacement at point C. So we're going to use the virtual work method. So we're going to first need to find real moment expressions for the whole beam and then virtual moment expressions for the whole beam. So let's talk about our real moments first. What are we going to need to find? Can we write a single moment equation for the whole structure? No. So we're going to have to write an equation that's valid from A to B, and then once we pass the concentrated force, we can write a second equation that's valid from B to D. Okay? I'm going to save a little time here, and I'm going to go ahead and look at my reaction at A and my reaction at B. So let's go ahead and find those values real quick.
Wait, B.
Oh, sorry, D. Force of habit, huh? Okay. So let's sum the moments about A. Make sure it's in equilibrium. So the 16 kip force creates negative moment about A and has a moment arm of 10 feet. And then the reaction at D creates positive moment with a reaction of 40 feet. So it looks like the reaction at D is going to be equal to
30.
Say that again?
Oh, no.
It looks like 4. Does that look right? And then we can sum forces in the y direction. We'll have my reaction at A plus the reaction at B, and then of course the applied load, 16. So it looks like the reaction at A is equal to 12. Does that look okay? Okay, so let's find our real moments, is what I'll call them. Alright, so finding the real moments. I'll need one that's valid from 0 to 10. So I'm going to cut my structure somewhere in that. Do you want to work the left side or the right side? Yeah, the left looks the easiest. So I'll draw a little free body diagram for that left side. So I'll have the reaction at A, which we know is 12. I'll cut it at some arbitrary distance x, and I'll look for the internal moment there. See that? So it looks like if I assume right-hand rule again, and some moments at the cut, I get the internal moment m. Then I have the 12 kip force creates negative moment, so that's 12 kips times x. So it looks like the moment there is equal to 12x. Can I see that? All right, one down, one to go, right? So let's look at the value from 10 to, what's that, 20, 40. So now I'm going to cut it somewhere over there. And you have to decide whether you can work the left side or the right side. What do you think? Well, the left side's got this additional force to deal with and a reaction. So the right side might be a little easier. You just have one reaction. So in that case, I'll draw a free body diagram of the right side. The reaction on the right side is 4 kips. And of course, the cut is occurring at some distance x. So what is the length of that section? Yeah, the total distance minus x, which would be 40 minus x. And I'm still worried about my internal moment. Well, that's why I'm not worried. I'm trying to find that. So now I sum moments. About my cut here that I've created. And what do I have? Well, I have the internal moment, which is negative. Then I have my 4 kips, which creates positive moment about the cut, times a moment arm of 40 minus x. So it looks like my moment is just 40 times 40 minus x. So maybe about not quite halfway through the problem. Okay? And again, on the first exam, or if I just ask you to write the moment equations for this, you'd be done. But we're not. What do I have to do next? Well, I have to create my virtual system. Now this problem is looking for what? Displacement at C. So I have to rewrite this problem, and I have to put my virtual load at C, which is right in the middle. And I'm assuming that it is acting down, and then I'll have reactions at A and D for that system. Now, I don't usually like to do this, but I'll shortcut this a little bit because you can see the load is right in the middle. So what are the reactions going to be? They're going to be equal. So I know my reaction at A is the same thing as my reaction at D, and they're equal to 1/2. If you wrote the equations of equilibrium, you'd find that probably in just an extra minute or two. So now what do? I need to find the virtual moments for this virtual load. So just like we talked about before here, where I need to write one equation from 0 to 10 to capture this moment, and a second from 10 to 40. In the virtual system, I have to go from 0 to 20 and write one equation, and then from 20 to 40 for the second. So let's do that. I'll kind of put a little squiggly line there. So let's do from 0 to 20 for this system. So I'm going to cut it somewhere here. Left side or right side? Yeah, I think the left side is going to be a little easier to deal with. So I'll draw a free body diagram for that. I know my reaction at A is 1/2 at some distance x, and I want the moment. Now this is a virtual moment, so I'm going to use the lowercase m to distinguish that. And if I sum moments at the cut, make sure they're in equilibrium, let's see what we get. So the virtual moment is positive. The reaction creates negative moment with the moment arm of x, so it looks like my virtual moment is just x over 2. Okay? So now we have to go from 20 to 40. So I'm looking at a section here. Do we want to look at the left side or the right side? Yeah, I think the right side is going to be a little easier to do. So I'll draw a free body diagram of the right side. The reaction at the right edge is still 1/2. And we know that the cut measured from the left is at some distance x, and that leaves us a segment of the structure which is 40 minus x. And of course we have the internal moment, which I'll assume is positive. So now we sum the moments about the cut equal to 0. Starting with the moment, that's negative with my sign convention. And then I have plus 1/2 times the moment arm of 40 minus x. So it looks like the virtual moment is 40 minus x divided by 2. So now I have moment expressions for the real load, moment expressions for the virtual load. Now remember, the equation that I want to solve says the displacement at C is the integral over the whole length of the moment, the virtual moment, divided by EI, and you integrate it. So how are we going to break this up? Well, I know my real moment varies from 0 to 10, and I have another matching virtual moment that also goes from 0 to 10. Right? Now, I have a real moment that goes from 10 to 40, but notice what happens over here is I don't have a virtual moment that goes from continuously from 10 to 40. So I have to stop at 20 and then do a third integral from 20 to 40. Everybody see that? So let's write that out. So I'm going to start with the first piece, 0 to 10. The real moment is 12x. The virtual moment is x over 2. I probably should have factored out the EI to make it easier, but I didn't, so there we go. We're going to add to that the integral from 10 to 20, where my real moment switches, right? What's my virtual moment? Still x over 2. Again, divided by EI, and we're going to integrate that in x. And then finally, I can match it from 20. I'm going to have to shift it down here. Sorry, I didn't organize this very well. So I'll go from 20 to 40. My real moment from 20 to 40 is still this value, 40 times 40 minus x. And now I switch to this virtual moment. That 1/2, let's make that a 2. How about that? See that? And I can just make that 40 minus x squared. Everybody see that? Sorry for the... Can't really erase. So I just have to process all that to get the result. Now for this problem and for this example, I'm just going to leave it like that. Because class is over. But I think you could probably very easily finish that off. In fact, I may ask you to do that for homework. Just pick this up. Well, actually finish this problem. So just go back through and verify that all this is correct. Do the integrations and divide by EI, because I did give you values for E and I, and tell me what the displacement at C is. Now you can check this too, because if you look in the front of your book, there is a general form for a simple supported beam with a load P on it. We know what our P value is. We also know what A and B are. And if you go over here and you see there's an equation that's valid from 0 to A, you would just evaluate that at, oh, wait a minute, I forgot. Never mind. That's going to be a little harder to do for our problem. So, yeah, don't do that. I'll show you how to use this later. But there are forms that you can check. I'm sure you could go online and find one that's easy. So you shouldn't be left out in the cold in terms of what the correct answer is. Okay? Any other questions before we go? All right.